In chemistry, balancing chemical equations is an absolutely vital skill. Now, the whole reason that we do it is because, as we said in the video for question 1, mass is conserved. Not only is mass conserved, but the types of atom that you start off with, you'll have the same number of them at the beginning as you do at the end. You can't just make new elements in a chemical reaction. The only thing that's happening there is that electrons are being moved around. The elements themselves, the atoms, stay the same in that regard. Okay, so the nuclei don't change, it's only the electrons. So as a result, that means if we had 2 atoms of chlorine at the start of a reaction, we got to finish with 2 atoms of chlorine at the beginning. So we look at this equation that we've got on the screen now, and we can see that we've got Na, so we've got sodium, is reacting with F2, which is fluorine, to form NaF, which is sodium fluoride. Now, there's lots of different ways that you can approach balancing an equation. The way that I'm going to do this is I'm going to kind of do a table method. So I'm going to write Na at the side and F at the side here, just so I can count up on the left and the right hand side of the arrow how many of each type of atom I've got. So we'll start off with sodium. So we've got 1 atom of sodium on the left, we've got 1 atom of sodium on the right. That's balanced, brilliant, okay, no problems there. Now let's look at the fluorine. We've got 2 atoms of fluorine on the left, denoted by that F2, so I'm going to write 2 there. And we've got 1 atom of fluorine on the right. Oh, that's not balanced, so we've got an issue, so I need to do something. Now, you might be thinking to yourself, oh, I know what I'll do. I will just put a little 2 in there. Now, you're not allowed to do that because that changes the identity of the substance that's been formed. The only thing that you're allowed to do when you're balancing equations is put big numbers in front of the substances because it's all about ratios. So if I want to have 2 F's over here, I need to put a big 2 in front of NaF. So what that's done, well, it's given me the 2 fluorines like I wanted, but it has caused another issue. It's given me 2 sodiums on the right hand side of the arrow when I only had 1 before and it was balanced. So I'm going to need to do something else to finish balancing this equation. Fortunately, it's not too tricky. Hopefully you've seen we've got 1 sodium on the left. So what that means I can do is I can put a big 2 in front of the sodium, the Na, over here. And now we've got 2 atoms of sodium on the left, 2 on the right. So that's balanced. 2 atoms of fluorine on the left, 2 atoms of fluorine on the right. So that's balanced. So if you got that right, brilliant. That would be worth 1 mark. Now we move on to a slightly trickier one. Okay, so this time, and I'm going to write out the equation again. We've got Li, which is lithium, reacting with HNO3, which is nitric acid. So we've got a metal reacting with an acid. And when we have a metal reacting with an acid, we form a salt, which is in this case lithium nitrate, plus hydrogen gas, H2. And we need to balance this one as well. So let's consider this. We've got Li, we've got H, we've got N, and we've got O. Those are the 4 elements we've got in there. So I'm going to use my little table method again. And I'm going to count up, first of all, my lithium atoms. So I've got 1 on the left, and I've got 1 on the right. That's balanced so far. Fantastic. Now let's look for hydrogens, H's. So we've got 1 on the left-hand side in HNO3. We've got 2 on the right-hand side in H2. That's not balanced. We're going to need to come back to that and sort that out in a minute. Nitrogen, we've got 1 on the left in HNO3. We've got 1 on the right in LiNO3. So that's all fine. And then our oxygens, in HNO3 we've got 3, so there's 3 on the left, and then in LiNO3 we've got 3 as well, so there's 3 on the right. So everything's balanced except from the hydrogen, so I need to do something about that to start with. So we've got 2 on the right, so I need 2 on the left-hand side in order to balance that. Well, at the moment, I've only got 1, so what I can do is I can put a big 2 in front of HNO3. So if I do that, I've now increased the number of hydrogens to 2, but I've also changed the numbers of some of the other elements as well. So now I've got 2 nitrogens in here, and I've got 2 lots of 3 oxygens, so 2 times 3, which is 6 lots of oxygens. Okay, so now our nitrogen and our oxygen is not balanced, so we need to do something about that. So on the right hand side, what we can do, because we've got 1 nitrogen here and 2 on the left and 3 oxygens here and 6 on the left, we need to times those both by 2. So we can put a big 2 in front of LiNO3. So if we go through the process again, our nitrogens, that's gone up to 2, so that's now balanced. 3 lots of oxygen times by 2 is 6, so that's now balanced left and right. But we've also added another lithium. There's 2 of these now. So now the lithiums aren't balanced. So now I need to look at those. So I've got 2 on the right, I've got 1 on the left. There's a lithium on its own on the left-hand side of the equation. So what I can do is I can put a big 2 in front of it. And now if we compare the numbers for each of these elements, lithium 2 and 2, hydrogen 2 and 2, nitrogen 2 and 2, oxygen 6 and 6, this is fully balanced. If you got this as your balanced equation, give yourself a tick. This isn't an easy skill to develop, but it is a really important one. So if you are getting it, really well done. Okay. Finally then, we move on to 5C. This time we've got an example of a combustion reaction. So we've got C4H10 plus O2 goes to CO2 plus H2O. Now, a little word of advice for a combustion reaction. These ones are always easier if you do them in alphabetical order. So there's 3 elements here. There's carbon, there's hydrogen, and there's oxygen. Okay, so in the order of the alphabet, C, H, O, it's easier if you do it in that order. Now, the reason why is simply because if you look on the left and the right-hand side of the arrow, there's only one substance on the left that contains carbon. There's only one substance on the right that contains carbon. So that'll be easy to balance. There's only one substance on the left with hydrogen in it. There's only one substance on the right with hydrogen in it. So that will be easier to balance. Oxygen, there's one substance on the left, but there's 2 substances on the right that contain oxygen. So that can be a little bit harder. Okay, so let's go through this then. Let's do our carbons first. So we've got 4 carbon atoms on the left-hand side. We've got 1 on the right-hand side. So we're going to need to do something about that. We've got 10 hydrogen atoms on the left-hand side. We've got 2 on the right. We're going to need to do something about that as well. Oxygens, we've got 2 on the left, and then we've got 2 compounds, as we said earlier, that contain oxygen on the right-hand side. This one contains 2, this one contains 1, so we've got 3 in total. So all of our elements are unbalanced. That's not very good. So let's go through this in the order that I suggested. Let's start with our carbons. We've got 4 on the left, 1 on the right. So that means we need to get ourselves up to 4 on the right-hand side. So if we put a big 4 in front of CO2, that does the trick. So that means we now have 4 carbons. But remember, we've also increased the number of oxygens here. So we've gone from having 2 to 2 times 4, because we have to multiply those numbers. So we now have 8 oxygens here. So now, in total, we've got 9 on the right-hand side, 8 plus 1. Now let's deal with the hydrogens. So we've got 10 on the left. We've only got 2 on the right. So we need to put a number in front of H2O that will multiply by 2 in order to give us 10. So the number that we can multiply by 2 to give us 10 is 5. 5 times 2 equals 10. So that means hydrogens, we now have 5 times 2, which is 10. And number of oxygens, we've got 5 times 1, which is 5. So now let's consider the number of oxygens we've got on the right. We've got 8 plus 5. That is 13. Now on the left, we've got 2. So the number we need to put in front of O2 just here needs to multiply by 2 to give us 13. Now if we do 13 divided by 2, that will give us our answer. Well, it's 6.5. But that feels a bit wrong because there's a decimal. We don't like there to be decimal places in our balanced equation. So we need to figure out a way to keep this ratio between the substances the same, but that we get rid of that decimal place. So the easiest way of doing that, because it's 6.5, 6.5, is if we multiply every single number by 2, that will give us our simplest whole number ratio in the balanced equation. So what do I mean by that? Well, I'm going to write it right at the bottom. Well, C4H10, we had one of them before, so now we can increase that to 2. 6.5 lots of O2. If we times 6.5 by 2, we get 13. 4 lots of CO2. If we times 4 by 2, we get 8. And 5 H2O. If we times 5 by 2, we get 10. So this would be your final answer to this question. Give yourself a tick if you got that right. As I said before, balancing equations, really key skill. The key thing with it is to be methodical, only focus on one element at a time. And if that route doesn't work, start again, start with a different element. Okay? Thank you very much.